So, good morning, everyone. A warm welcome back to day 4 of our Imagery and Remote Sensing webinar series. My name is Samkit Bagmar. I contribute to the Imagery and Drone Solutions business here at Esri India. It's fantastic to have you all back with us today. I could see a lot of people joining in from day 1, and there are so many new people as well who have joined in today. So before we get started, just a couple of housekeeping items. Firstly, if you have any questions during the presentation, please feel free to drop them in the chat box, the Q&A box at any point. Do not hesitate to write them. However simple you might think it is, but it is important for you to write. I'm sure it would help many other people who are there. We'll address as many as possible during the live session itself. If not, we'll take it towards the end of it. Secondly, for those asking for the recordings, yes, the full session recordings will be shared with all attendees after the series concludes. So don't worry, you miss a specific detail and you will get to revisit the workflow again. To ground today's session, let's take a quick look back at our journey so far. So we started on Monday, the day 1. We kicked off with GeoAI and deep learning, showing how artificial intelligence inside ArcGIS automates complex feature extraction, object detection, land cover mapping, and so many other things directly Pro. On day 2, we moved to desktop workflows within ArcGIS Pro for enterprise intelligence, examining how combining ArcGIS Pro Image Analyst with ArcGIS Enterprise Image Server allows organizations to stream dynamic image services and scale analytics across different teams within an organization. Yesterday, that is day 3, we explored ArcGIS Reality from drone to map, side scan, Reality for Pro, and Reality Studio, showing how to turn sensor data into survey grade 3D meshes, Gaussian splats, true orthos, and elevation models, which form the foundation for digital twins. Today, day 4, we shift our focus to advanced spectral processing and analytics with ENVI. So we'll be turning imagery into actionable intelligence through ENVI and deep learning today. So modern satellites, aerial imagery, and drone sensors are capturing richer spectral information than ever before. But raw pixel values only deliver real value when they are transformed into actionable spatial insights. ENVI is recognized globally as the gold standard for advanced image processing and spectral analysis. We seamlessly integrate this with ArcGIS that bridges the gap between deep image science and enterprise GIS workflows. So in today's session, we'll be exploring how ENVI leverages multispectral and hyperspectral imagery to identify subtle material composition, vegetation health, environmental changes that a human eye cannot ideally see. We will also see how ENVI's intuitive deep learning module makes target detection classification fast and accessible, allowing you to train robust models without the needing of custom coding or anything. Today, you will also see how these powerful image analysis capabilities transform complex datasets into critical real-world intelligence. To lead us through today's presentation and live demonstrations, I'm delighted to introduce you to our speakers today. So we have Manjusha Singh. She leads the imagery pre-sales team here at Esri India. And we have Shreya Roy. She is, again, part of our imagery pre-sales team who works closely with Manjusha in our team here at Esri India. So both of them bring extensive experience in remote sensing, spectral analysis, deep learning workflows, also domain-specific knowledge for agriculture, forestry, mineral mapping, and so many other things. So we'll be showing you step by step how to unlock true potential of ENVI in this session. So without any further delay, let's dive in. Shreya, over to you.
Thank you, Samkit. Please confirm if I am audible and my screen is visible to all.
You all can drop a thumbs up in the chat box. Yeah.
So thank you all. It is a pleasure to have you here and hope you will find the session informative, insightful, and valuable. As Samkit has already mentioned, last few days we were looking about the ArcGIS Pro and its various capabilities in the geospatial domain. Today I will be talking about ENVI and its various image processing capabilities. I will also cover some of the key modules and functionalities of ENVI like atmospheric correction, feature extraction, change detection, and other advanced image analysis techniques, which will be talking, which my co-speaker will talk in the later half of the session. So as we know, ENVI is an end-to-end imagery analytics platform supporting 245 plus sensors and 70 plus data formats, and it has reusable workflows via ENVI modeler. Suppose your colleague is working on a complex model and in ENVI, and he or she wants to share it across the team. He or she can publish the model in the repository, and the team member who wants to customize this model can use that model instead of developing it from the scratch. Apart from that, your ENVI output can be seamlessly integrated to the ArcGIS environment for better decisions and visualization purpose. This also helps into transfer imagery into actionable intelligence through classification, material identification, crop monitoring. So let me talk about the different use of ENVI. ENVI has a seamless modular architecture where you can quickly and easily perform highly specialized tasks that require advanced image analysis tools. Suppose you want to remove your atmospheric interference from imagery, you can use atmospheric correction module. If you want to extract some specific objects like buildings or water bodies, you can use a feature extraction module. If you are interested in 3D digital elevation model or orthophoto, you can work with DM extraction or photogrammetric model. Apart from that, ENVI has a suite of deep learning model where no programming skills are required. It works on a no-code basis, and you can quickly retrain and create your classifiers. Also, ENVI has a separate suite for precision agriculture, which comes under name as crop science module, which helps to monitor crop health and detect plant stress. These insights you can take down for your further analysis for harvest and yield prediction. Now let us look into the capabilities of atmospheric correction model. So ENVI has two types of atmospheric correction modeling tools for retrieving spectral reflectance for both multispectral and hyperspectral radiance images, level 1 at sensor radiance images. These are QAC and Flash. Suppose you have a satellite data where your metadata has limited of sensor information, you can go for a QAC, but the information may not be accurate. We prefer to use a Flash, which is a physics-based correction, and it also uses the aerosol optical depth and removes the effect of water vapor or haze. So let us see through a demo. Is it visible? So before showing the demo, this is the environment of ENVI. Let me showcase you. You can have a rich number of optical sensors and radar sensors where ENVI supports. Even if your sensor is not listed here, you can also ingest your data in military format as scientific format. But the difference is that if you are ingesting your data in not a native format, your metadata information may not be populated. Then you can edit your metadata and you can add those information. So let's go to the atmospheric correction module. So on the left hand side, I have an image of Sentinel-2 level 1C data, and I want to do atmospheric correction using Flash. Okay. So these are the different bands. Like in Sentinel-2, you have a 10-meter, you have some 10-meter band of visible and near infrared. You have 20-meter spatial resolution band, which is mostly of sweep, and you have a 60-meter band. So I will be mostly working into the 10-meter. So you see, since I have ingested that image based on the native format, so the metadata has already come and I don't have to populate it. It is a 4-band imagery of visible and near infrared. The image is of 10th January 2026 and the timing is also there. In sensor, Sentinel is not listed here, so I have kept it as multispectral. Then the geometric model is already, it has taken from the metadata. Then for model, so for atmospheric model, there is ENVI supports a help file where you can check based on the latitude what atmospheric model you will look into. So my study area is around the latitude of 27 degrees. It's a place in Uttar Pradesh. So I have chosen tropical model. So water, you can take automatic selection, but since Sentinel-2 already have a water absorption band, so for better insight, I have taken 940. For aerosol, I have taken low visibility rural because this is mostly, you can see, this is an agriculture area. So I have chosen low visibility rural. If you are interested to remove haze for an urban area, you can use a low visibility urban. Then use aerosol. You can use automatic. I have used vegetation based retrieval because I want to clear the haze on the which is there on the agriculture field. So this you keep as it is. So if you click next, this is what the output I will get from the flash. So by seeing in the naked eye, maybe you will see that both the images doesn't make any difference. But let us compute some spectral indices and see how flash has helped to get a better insight. So what I did a normalized difference vegetation index of both the uncorrected image as well as the corrected image. The corrected image is on my right side. And after doing the NDVI, I did some density slicing. So you see this difference? So what happens, like ENVI, there was some haze in the image because it was in the month of January. So ENVI, after doing this atmospheric correction, ENVI has actually cleared the haze and helped to get the near accurate information which is visible on the ground. So whenever you will do this type of studies and you want to do further analysis, like you want to see whether your vegetation is of a good health or a moderate health. So this type of insights will help you understand, because in the uncorrected imagery, the value is still in 0.49, which we used to consider depending on the crop type. Suppose if we are talking about wheat or so, we used to consider 0.45 as a moderate. But here, apart from 0.49 to 0.55, usually it goes to a good category. So this type of analysis will help you to get a better insight. Just 1 second. Sorry for the delay. Sorry, 1 second. Next, I will be talking about another capability of ENVI. Suppose you did atmospheric correction, then you want to do some insights like feature extraction. So the difference between a feature extraction and pixel-based classification is that in case of feature extraction, you used to work on an object where group of similar pixels having meaningful features like spectral, spatial, and texture information can be grouped into objects, and it accurately identifies such as buildings, roads. This is the workflow of the feature extraction, and I can tell you one thing. Sometimes you may not need a deep learning model to do this type of studies. Like if you are interested in a building footprint, if you are interested in road detection, you can, and you want a ready to faster insight, you can use this feature extraction module. So this is the workflow of the feature extraction module. First, it will do segmentation. So the process is that the entire image will be divided into meaningful segments based on your similar pixels having similar spectral, spatial, or texture attributes, and then you can do a merge. So while doing the merge, I think not clearly visible, but I will tell you. So this is the ENVI snapshot which I have kept, because for the interest of time, I have tried to keep the software snapshots in the slide itself for better understanding. So there are two functions. One is your age and one is segmentation lambda. So when you are doing age detection, because this helps how your segments will be grouped. Age helps the segment by finding the boundaries. There is another option called intensity, which actually works on the intensity of the spectral values, and sometimes it is not advisable to use intensity because it will create your smaller pixels. Now, if after creating this age, after making this age, then you want to group this into you want to merge this into different meaningful objects. So there is a function called segmented lambda schedule, which helps to refine those segments by merging into similar neighboring objects into larger and representative features. So if you are no, these are the threshold levels. Like if you want bigger objects, the threshold level of age should be a bit higher. We actually proposes, like depending on the size of the object, around greater than 50. And also in case of merge settings, also if you are not interested in smaller objects, you can keep your merge level also more than 50. So after the segmentation, there will be a class creation, where this is the second part of segmentation in ENVI. This is the kernel, that is 3x3 kernel. So based on that, ENVI has what ENVI has done. ENVI has segmented the entire image into meaningful objects. Now the next task is to train those objects into classes. Like if you are interested in extracting buildings, you will use those segments as buildings, and also you have to collect some background signatures also. The more better your signature collection will be, the more better and accurate results you will get. After doing the training, after collecting the training signatures, you can do an image classification. There are three types of image classification that ENVI performs. One is K nearest neighbor, one is support vector meshing, and another is principal component analysis. And in ENVI feature extraction, there are different types of feature extraction workflows. Like you can do a calculate cloud mask using F-mask algorithm. You can do a rule-based feature extraction workflow. Suppose you want to work with your NDVI images and you want to extract some land parcels or not, you can do a rule-based by giving some rules to the NDVI. You can use I will be showcasing a demo using example with feature extraction. So a brief about the demo. So I will be using this feature extraction module to detect the poly houses using, I have a high resolution satellite imagery of 60 centimeter. Someone doesn't know about the poly house, just let me tell you a brief. These are greenhouse structures which are covered with transparent plastic sheets that provide controlled environment for crop cultivation. They protect crops from adverse weather, they improve yield and quality, and enable year-round production for high-value vegetables, fruits, vegetables, and flowers. Now let us look into the demo. So this is my feature extraction workflow. I have used example-based feature extraction. And for the interest of time, I have already made my feature extraction. I will show you the output. So this is my imagery, and you can see the pixel size. This is 60 centimeter. So see, these are my poly houses which I have extracted. I did a 3 times iteration. Also, I will tell you there will be some noise in case of roads, because sometimes it happens the spectral value is mostly similar. So you can do a post processing. In there is also an option of post classification. You can do a post classification refinement, and also you can use the shape function, because obviously if you want to remove the roads, you can use the length of function, because road is a linear structure and your poly houses are rectangular structures. So by doing this, you can refine your results. Now, after making this type of, and ENVI also gives the output in the raster format as well as in the vector format. Now, after using this, after detecting this poly houses, you can take this output into ArcGIS for environment, and if you want to see, like in a particular village, how many polyhouses are there, or if you want to do some network analysis studies, you can use this output. I'm finding some problem with changing the slides. So my next demo will be on change detection. Suppose you have a 2 time period data of 2 different years, and you want to see how your land cover has changed over the years, you can use this type of studies. One thing is that while doing a change detection study, your month should be more or less similar, because if you're doing a change detection study using a monsoon and a post-monsoon image and try to find the change, you may not get a clear, you may not get an accurate change result. Okay? So there are different change detection modules like thematic change workflow. So this is my input data. This is the before data which I have, and after doing a change detection, this is after. I will show briefly in the demo as well. So while doing change detection studies, you have to have two input data of two time period, and also those data set has to be properly co-registered so that there will not be any pixel shift. One data should exactly sit on top of the other. Then you can do a change analysis. There are different types of method in ENVI. You can do through a ENVI. You can subtract between NDVI1 and NDVI2, and then you can do the change detection. Then there is spectral angle mapper as well, and you can do a principal component analysis. Then after doing the change analysis, you will have a change matrix, and there is a thresholding. So you can decide what threshold you will consider as a change and what threshold you will consider as a no change. After doing the change detection, you can give the output. Let us go check this through a demo. So I am interested. This is a study area. I hope by showing the images, some of you might be knowing what I'm actually showing and what is this places. So this is the image of 2018 of January month, full of agriculture crops. Then slowly, you see the land clearing has been done. And now say in 2026. So you can see the change, right? So what I did a classification of 2018, and my classes are built up in agriculture. Then I did a change detection. I did a classification of 2016 having the same class. Then I did a change matrix, and see, this is a change I found. Then I am actually interested into agriculture to build up. So this type of studies you can do in a change detection algorithm. Next, I will be talking about another capability of ENVI, that is crop science, which I have already mentioned. Crop science is a precision agriculture suite where you can get the count of the crops. Like suppose if you're working on an orchard crops or tree crops, and you want to know in my plot how many trees are there, you can perform this type of module. You can use this module. You can do hotspot analysis so that you can want to zero down, okay, which trees are in stress condition, which trees are actually having good. So this type of studies you can do it. So this is a suite where ENVI provides. Now I will be showing this with a demo. And let me talk about the brief about demo. So I will be showing crop science in oil palm plantations. So actually the month of January to March is very critical to these crops, as the crop vigor as the stage, it plays a deciding factor in determining crop yield. And you might want to compute, and if you want to compute yield, provided you have a historical yield of those areas, you can do a regression equation and find how your crop yield has changes. So I have a imagery. So here I have taken two imagery. One is my high resolution imagery, where I have used to denote the count crops. These are the oil palm canopies. So before that, I did a band enhancement, because this algorithm, this count crops takes a single band as an input. You can use a thematic layer also. I have used this image has a RGB band. It's a 3 band. So I have I did a spectral subset for the green band, and I have written this. Then I did my precision count crops. So I have already pre-filled this. So this is my green band. This minimum crop diameter and maximum crop diameter actually depends on the canopy size you want to of the crop, which of the tree which you want to identify. Number of increment is basically the number of iterations. The smoothing factor also depends how much you want to keep, what is your noise. And this allowable crop overlap and intensity, it depends like if there is a difference between two canopies. So whether you should consider it a single pixel, single count, or whether you should consider, so this type of this type of this type of workflows helps to do that. So after that, let me show you. So this is my shape of the oil pump, where I have created this counts. Also, the best part is that you can have a raster fill input also. Now, after doing this crop count, now I am interested to see how the health of this particular trees are. So I did calculate crop metrics with spectral index. So I have a Sentinel-2 data. This is a reconstructed data which is having a 2-meter spatial resolution. I am not using a 10-meter Sentinel data here because since I am interested in tree crops, so my multispectral data should be a higher resolution to give a better insight. So calculate crop metrics. So here, what is I have to get input your oil pump band, then your green band. Then you can do different indices. So first, what I did a leaf area index, that is LAI. Okay. So I will be interested in this portion. So LAI basically denotes the leaf area, what is the actual leaf cover present in your particular tree. Now, it doesn't mean that a good leaf area will have a healthy crop. Let us look into this. So apart from LAI, I did a NDMI study. That is my normalized difference moisture index to see what is there in any developing crop stress in my particular trees. Also, I did a red edge index. That is, I want to see how my health is there, because when your tree is at the critical stage, like when it is at a maturity stage of flowering stage, NDRE gives a very useful information. So now you see, like this portion, even if my LAI is good, my red edge value is actually on an average, and my NDMI values also, it is quite average. So it might happen that there is some moisture stress. So this type of studies, and now as I have already mentioned, this type of insights you can take further for your yield computation. So now let's talk about the hyperspectral capabilities of ENVI. Is it visible? So till now you have looked into the multispectral imagery, which helps you to basically it helps you to discriminate between different objects. Now hyperspectral, as you have seen, it has more channels, obviously more spectral channels, where the radiometric band resolution is very high, and you will be having a deeper insight. So I will show you something in the slide. Suppose this is a broadband imagery of Landsat. This is a spectral signature, and this is the hyperspectral imagery. You see how the graph is changing. So there is a gap because of the band. And I will specifically, I want to draw your focus on two different curves of a healthy vegetation and a stressed vegetation. This is a typical vegetation curve. So in case of healthy vegetation, you see here, this is we used to call a red edge inflection point. So in case of healthy vegetation, the NR reflectance is high as compared to red reflectance. So you will get a high NR band reflectance as compared to a stressed vegetation, where the red reflectance is comparatively higher as compared to NR band. So the red edge reflectance will be shift. We used to call it red edge shift. There are also different indices which can be done in a hyperspectral analysis suite. And different workflows you can do, like you can do an agriculture tree classification, you can do water pixels. And now the demo which I am going to show is about mineral identification. You can do forest analysis. So a brief about the study area. So this is a portion of Bhilwara district, and mostly the geology is mostly of mica bed, and there are some sand dunes also. So I did a spectral hourglass workflow, and I based on the spectral hourglass workflow, I will show you here. Yeah. So in a spectral hourglass workflow, first what it is, it does a minimum noise fraction, MNF. So in case of MNF, it helps to reduce your data dimensionality because hyperspectral data is having a large number of bands, but most of the bands are not after your speed band, most of the bands are not useful. So you can do a data dimensionality through MNF so that the number of bands will be reduced. You can see after band 30, then the curve is getting flat. So after MNF, we are reducing our band. Then we do a pixel purity index, which basically uses those bands to give your pure pixels, which you can be used for collecting end members and doing a further classification. So these are my end members. So these are my end members. Now I will show how are we identifying, okay, this is my, how I can identify it, okay, this is what class, this is what class. So let's look it. ENVI has a material identification tool through an n-dimensional visualizer. So yeah. So I am interested, what is class 10? Okay, this. So based on ENVI, sorry, I am interested, what is class 10? That is this part. This part. So based on your n-dimensional visualizer, and there are 5 methods which gives you, it is some acid mine drainage is might be there. There is a probability. We can't tell it. This n-dimensional visualizer actually talks about the probability. So this is the acid mine drainage in class 10. I will be interested about what your class is, class 3, as class 3 and class 2. So there are some sands also. So the class 9, which is showing as a white crust, this is coming as a white crust. So this type of studies you can do with hyperspectral analysis. So after this, let me shift into advanced capabilities of ENVI through machine learning. So till now you have seen about the traditional classification and the easy things of this. Now machine learning is one of the advanced capabilities where it works on a ML workflow, where it automates your image analysis, and the machine can take the data and based on the training signature, because you need to give a training signature, and you can perform a different types of classification like live phase, random forest, extra trees, and you can do a machine learning. Let me show you the demo. So I have used a naive-based classification. So I just want to tell, while doing machine learning algorithm, the input data, sometimes it happens if you want to perform a machine learning algorithm using a multispectral singlet data, it might happen that your some classes will remain unclassified. So it's better to use a multi-temporal data at single band. Like I have done. This is a study area around Agra, Bath Tehsil of Agra, and I have taken a multi-temporal data from November to December to March, so that to have the entire crop calendar, because it's a Rabi season and most of the crops are here like mustard, wheat, potato. So I have layer stacked the 5 dates. So this is my input raster. These are the input ROIs. And also you need to do some background, you have to take some background signatures as well. So after doing this, these are optional. And this is my output. So let me tell you, this is wheat. This green color is wheat. Then this pink is mustard, and this is potato. Let's throw this. So as I here I will hand over to my co-speaker Manjusha, who will be taking into more advanced capabilities of ENVI through deep learning. Over to Manjusha.
Thank you, Shreya, for this insightful session. I'm sure most of us have now come to know about the recent capabilities of ENVI. Artificial intelligence. Let me discuss the artificial intelligence capability within ENVI. AI is transforming the way organizations analyze the data, make decisions to improve operational efficiency. By combining the machine learning and deep learning capability, AI enables us to identify the pattern, generate accurate insights, and automate complex tasks with greater speed and precision. ENVI provides an integrated suite of AI-based tools that empowers users to rapidly classify, map, and detect features in the imagery. Even if you are not an expert, since this is a no-code, low-code solution, you can use ENVI to create your deep learning models. All the models are done using the training sessions. So before deep diving into the deep learning, let us take a few minutes to pick the right solution for your application. ENVI offers a wide range of tools for image analysis. This table will help you to choose the best one for your specific needs. Like Shreya mentioned, there are traditional algorithms and classification techniques that can help you to classify your images. However, machine learning improves the accuracy, scalability, and automation, especially when you are dealing with large data sets and complex analysis. For example, in case of land cover classification, you can use the traditional method and apply the thresholds and rule-based classifications. However, machine learning algorithms such as random forest, SVM, or knife-based with the selected features such as spectral bands and ENVI can help you improve the accuracy. Deep learning, however, uses the CNN and RCN models to learn the spectral, spatial, and textual features and directly from the imagery without manually defining it, and can be used for a wide variety of applications and large data sets as well. So as Shreya has demonstrated the machine learning using the knife-based algorithm, how it can be used for top classification, I will take you through the deep learning process. ENVI deep learning supports or uses Onyx model, which is an open neural network exchange. So any deeper learning model, since it's a no code, would help you to train the samples, create the models, and evaluate your performance. Since Onyx is an open source model, you can create your, you can bring the open source models from an open source domain within ENVI and use it for your applications. If need be, you can further retrain those Onyx models to create your own ENVI Onyx. Since these models are very hard to create and can utilize most of the resources, what we do is we have also the capability of analytical repository. These analytic repository helps you share the models or the images or even the workflow modelers within the within your organization for anybody and everybody to use. Not only that, ENVI deep learning also allows you to visually enhance your images to finally use your models. ENVI Onyx uses, there are many frameworks which can convert your models to Onyx, such as PyTorch. You may have your I would say models that are created in TensorFlow, Keras, PyTorch, or XGBoost, or say MATLAB. Those can be exported onto Onyx format. In the right hand side, you can see the entire suite of deep learning module that is supported within ENVI. It not only gives you the entire module, but it also helps you test your own system, whether it is compatible for your deep learning processors or not. As can be seen, my system is properly configured and ready to run the ENVI deep learning. It will not only give you what the license, what is the version, etc., but it may also tell you the pixel segmentation, the deep learning models, or the object detection, They are all tested and we are good to go with to create our own deep learning models. So the model configuration within Onyx requires the input, that is the preprocessor and a post-processor. These preprocessor would allow to understand how to match the input with the Onyx models, such as it will give you the normalization, the resizing, or the dimension conversions, and post-process will help you help the model understand how the output would be. There are three methodologies within deep learning models. The first one being the pixel segmentation, that will give you the that will segment the images into various classes, or I would say various classes that the user tells. Next, there is object detection that will give you the give the bounding box as an output for whichever object of interest the model has been trained for. And finally, the grid. So the grid allows grid formation. Grid models will allow the grid formation to be done near the object of interest. So in this case, if you can see, there are grids around the clouds that is available. This gridding will help you to run the resources, or I would say use the resources efficiently. This is how the tensor board would look like. So whatever ENVI model does, what it does is it will take the performance matrix onto a tensor board interface, as can be seen. It will allow you to help converge the model. It will give you the matrices that will help you to make the confusion matrices, and finally have understand whether your model is performing well or not. As I've already said, these models are very hard to create and may require a lot of time and effort. Therefore, it can be shared within the organization using the repository workflows. These workflows would help you, these workflows or repository will help the entire community to use it. This is, we can share both the machine learning as well as the Onyx model onto the repository workflows. This is so looking at the we can publish it using our own system onto the central location. Let me demonstrate the deep learning capabilities to you. So this is the deep learning module, as well as there are machine learning algorithms that were just discussed. So machine learning has unsupervised, supervised, as well as anomaly detections, for which the models can be generated and we can train. Similarly, within deep learning, we can have pixel segmentation and object detection. So ENVI deep learning can help you build your own model from the scratch using the step-by-step wizard, which is just shown. That is, if I want to have a pixel segmentation model, I can train the new model step by step with for say a particular class, or for the or for multi-class as well. Otherwise, we have these capabilities to get the open source model, which I'll be discussing in a bit. For this particular demonstration, I built my model from the scratch, wherein I have tried to identify the fonts that are available. So using the pixel segmentation workflow, what I did was I could label my raster. So we have a dedicated deep learning labeling tool that allows me to open my or I would say use my labeling techniques. So here, as can be seen, all my classes and all my polygons have been digitized for different ROIs and different images on different images. So for my stack one, I have used my different ROIs that can be seen. Using these as this as my training samples as my base, what I can now do is I can train my deep learning model, and finally I can evaluate my performance. So in the interest of time, I've already done this for an area that is near Gujarat. So as can be seen, most of the water bodies are very clearly delineated using my deep learning model. So this is how the pixel segmentation would look like. Once I'm training my model, I would also like to show the tensor board workflow. as to how the all my models are converging, and the different confusion matrices that was created while building these models. Next, so just to summarize, this was how I can build the entire model from scratch. Next, I would like to show how we can configure an Onyx model. So what I did, in this demonstration was I brought my model that was in Onyx format within my interface, and I had to write a bit of a pre-processor and the post-processor script so that my model understands which what is my dimension, how the model was created, what was the image width and size, and all those details. So those details are present within my pre-processor and my post-processor scripts. These are generally written in Python. We can use the Python script that is my VS Code as well. So once these processor scripts are validated, so what it does is, based on the model that I've just input, I have preprocessor validated. Similarly, I can use my post-processor to be validated. I can enter the number of bands and the image width and size. Next, on the output, I can see that yes, oil storage is already available for my class name, as this was a pre-trained model that I had just put. Further, I could also give the details of the various model that I've used, the architecture that I've used for further references. Once we have configured this Onyx model, I can use it to validate, or I would say infer it on a different area. So I have used the Sigma board input raster to validate my model. So as can be seen, there are confidence threshold and intersection union thresholds. Those can be adjusted. However, here, as can be seen, I have my model architecture that can be seen, how many bands of image was there, how many classes can be modified. All those information are present well within my on the interface itself. And it not only gives me that, it also gives me the model information as to when it was created, on how many bands, and what was my image width and size. We can also look at the preprocessor script that was used. So these preprocessor script is written, as can be seen, in Python, which requires a bit of tweaking, etc. Once I have my, once all these are ready, we can also use both the CPU as well as the CUDA port that is available. So generally the deep learning models require a lot of GPU for processing, etc. So we can, however, ENVI allows you to work on any either the CPU or the CUDA port that is available. Once I have my deep learning, this is the output. Once I've run my model, this is the output that was created, not only for this particular image in particular, but also for a different image. You can see how accurate the model is. If the open source model is not accurate, we also have the liberty to train it within ENVI itself and retrain and get a new output. Next, what we can do is we can publish this to a central repository, as I was telling. So once I have my model, it will give me all the details that is available. And finally, I can give the repository to any particular centralized location. In this case, I'm using the centralized location here. Once this is published, this is the sort of log that will be shown, and it will tell you that fine, you have successfully loaded the Onyx model, and all the details of the model is present within the repository log. Let me show where this repository case will be. The repository will reflect the workflow that I have just shared. So as you can see on the top, we have the oil storage model that was shared, that can be installed or edited or can be downloaded by any other person within my organization, since this is a centralized repository we are talking about. ENVI gives you the liberty to add any repository, provided it has to be a URL and a port name that should be available. So here in my desktop, you can see there are two available ENVI repository. One is my own system, and the second one is the demo one dataset, demo one repository that I have configured. The different information of the same can also be viewed here. So this is mostly about the object detection and the pixel segmentation deep learning capabilities within ENVI. Let me move on to the agentic part of the ENVI deep learning modules. My previous is going. So ENVI agent is, in short, if I have to say, it is articulate your goal and let the ENVI agent handle the rest. It enables you to be more efficient by helping to plan and execute remote sensing workflows. It simply describes the problem you want to solve and generate the results without clicking buttons within the ENVI. If you are an active participant in the process and help guide the decisions, refine the outputs, and adjust the direction to optimize the result. It summarizes the workflow before processing your data to make sure the analysis matches your intent. This enables you to do things you couldn't do before, move faster, and focus only on the results instead of managing these steps along the way. Similarly, Ideal Agent empowers you to automatically write, run, and troubleshoot your ideal code so that it understands the code and programming, making Ideal more approachable and enabling you to do more with your time. Ideal Agent helps you lower the barrier to ideal programming. Let me demonstrate the same to you. So as can be seen, I have my Visual Studio chat that will allow me to perform various. So here, as can be seen, I've used a chat that is from Visual Studio, wherein I have given it a folder and asked it to search for 2 timeline images and perform the change detection and display the results within ENVI. ENVI agent on its own is going through my folder, and finally, after the entire processing, it has fetched 2 timeline dates and has itself suggested that it will apply SAM image difference for the change detection. The outputs were generated and we can view the same. So see, it is that easy to work with ENVI agent. We just need to give the folder and tell it what to do. Using the workflows of ENVI, it will automatically detect how to work with this. This is just for the multispectral urban change detection that we will be talking about. However, the same can be applied to hyperspectral images as well, and we can perform the hyperspectral analysis or the machine learning analysis as well using the ENVI agent model. So as can be seen on the left-hand side, it has identified both the 20th October as well as the 23rd October date and timelines. And finally, given the output as 2023.dat. So for 2 timelines of imagery, I can very well see how the changes have occurred over the period of time. ENVI gives me the liberty to work with the workflows individually. However, agent has made it easy to work with. Let us now look into into some places where the major changes have taken place over the period of time. So as can be seen, this was initially a water body that was located within the area. However, it has changed to a built-up area over the period of time. Similarly, there was the water body that was largely available within the area of interest, and this was changed to an agricultural land over the period of time. And these were very clearly identified using the SAM change detection with the ENVI agent itself, itself suggested. Next, we have the geo agent. ENVI agent also works with the geo agent. So the geo agent allows me to. So the geo agent is your intelligent geospatial assistant that is designed to understand your mission, interpret your intent, and automatically build and execute end-to-end workflows. GeoAgent is an agentic AI, is a part of GeoAI that automates the discovery, analysis, and production of results, helping teams move faster, better decision, and scale the geospatial insight across the enterprise. So this slide majorly illustrates the overall architecture of GeoAgent system. User interact with the GeoAgent through natural language chat interface, where the requests are interpreted by the large language model into structured geospatial workflows. An orchestrator coordinates the execution by selecting the appropriate analytical tools from the modular analytics repository. The processing engine then performs the required GIS analysis using the data from centralized data catalog and scalable computing infrastructure. Finally, the results are returned to the user in an easy to understand format, enabling efficient, intelligent, and automated geospatial analysis without requiring GIS scripting or manual workflows creation. Let me show you how the GeoAgent interface looks like. So within GeoAgent, we have so this is the GeoAgent interface that we have here. In a very normal natural language, we have I have written that there is a severe flooding in and around the Assam area. Can you find the recent multispectral imagery which has less than 50% cloud? Since this is the since we are talking about the flooding event, definitely there will be cloud within optical images that we have. However, since I have already given it the threshold, or I would say I have asked it to only look for less than 50% of cloud over the point that is suggested, it will allow me to do. It has only taken these two images. I have also asked it to ask the timeline as say 1st July and the post event as 6th July. Since I have mentioned them, it has taken the images as is. So, like you can see, it has told me that yes, there was no Sentinel. So first, the thing is, it has using my natural language, it has gone through the entire Sentinel repository and found out the images that was available post and pre-monsoon, along with the cloud type that is available. So it has told me that fine for the post event, so it could find two images wherein the cloud cover was 23 and 33. Which one would I want to use? And the second, it told me that during the timelines that you've mentioned, is I could not get something under 50% of 50% cloud. So can I widen my search? So I've asked it to widen its search, and finally it could have one image that could be found for the area of interest. Once it has the images that was allowed, it has asked me that fine, let me know for the post which one would you want to work with, whether with the cloud of 23% or 33%. So I've asked it to go with the 23% cloud tile and give me the area that was flooded, or I would say changed. So it has again given me how it has tagged the entire image and done the pre-processing, etc. And finally, it has asked me whether you want to give the entire stack or how do you want. So it has given me the entire downloads of how the differences is. I can now download this and view it in a different application or within ENVI and do the further analysis. So point here being that we have used the normal natural language and changed it into something. The GeoAgent has helped me to automate the entire process using the large language models and other agentic AI capabilities, and finally giving me the output for the desired area of interest and timelines that I prefer. So this was mostly about the GeoAgent that I wanted to talk about. So to conclude the session, ENVI is a comprehensive image processing software that can be performed, that can perform end-to-end processing, including the atmospheric correction, that is flash, to generate the analysis-ready satellite imagery, like it was demonstrated. It can also process and analyze the multispectral and high-resolution imagery for a wide range of applications such as mineral prospectivity, mapping, or I would say crop analytics for canopy counting and health assessment. It can also monitor land use and land cover changes over the period of time, enabling applications such as urban expansion, agriculture conversion, and infrastructure monitoring using change detection, classification, or other target detection workflows. It can automatically detect and extract features such as polyhouses, buildings, roads, and other objects from high-resolution imagery. Finally, it can leverage machine learning and deep learning capabilities, including Onyx. Problem connected to the second. Sorry for the technical glitch. Thank you, Abhishek. So I would summarize the summarize the session. So ENVI is a comprehensive image processing software that can perform end-to-end processing, including atmospheric correction, to generate analysis-ready satellite imagery. It can process and analyze multispectral, hyperspectral, and high-resolution imagery for a wide range of applications such as mineral prospectivity, urban planning, infrastructure monitoring, or canopy counting, etc. It can monitor the temporal changes for applications such as urban expansion, infrastructure monitoring, which largely requires the continuous monitor to understand how it has developed. It can automatically detect and extract the features such as polyhouses, buildings, roads, and other objects from high-resolution satellite imagery. ENVI can leverage both the machine learning and the deep learning capabilities, including the Onyx model support for accurate detections, classification, and image segmentation across diverse remote sensing applications. So whether it is building footprint extraction, it is road extraction, oil storage, etc., or the classification of your number of crops over the period of time can be done using the machine learning and deep learning capabilities. It can support next generation geospatial intelligence, and using the Geo AI capability, it can accelerate the analysis through these AI agents and geo agents that automate the workflow, support change detections, and enable faster data-driven decision making. Thank you for the session. Over to Samkit.
Thank you, Manjusha. Thank you, Shreya, for this incredible presentation and live walkthrough through ENVI and other deep learning analytics that we have to offer on ENVI. So we have had some fantastic questions come through in the Q&A during the session. So we'll spend some time, next few minutes, addressing some of those questions from the audience. So I'll read them out. You can respond to them. You can as well scan this QR code and give us feedback on the today's session meanwhile. So I'll read the first question. I think a few of the questions have already been answered in the chat box though, but I'll respond to the ones that have not been. Have you answered all of them, Ashish? No, there are some. Why do I not see them? Okay, got it. Yeah. So in the water body detection slide, it appeared that some cloud-covered regions were also detected as part of reservoir. Since the method uses deep learning, how does the model distinguish clouds from water?
So definitely, if I would have identified or I would have used a much rigorous data set or much rigorous samples that were available, it would have not even identified the cloud as well. It would have majorly distinguished between the water body. So these models, I would say, is mostly efficient depending on how the samples are available. So if I have given that sample, it will.
Okay, I hope that answers the question. So the next question is, for your polyhouse detection workflow, which satellite imagery did you use? If native high resolution imagery was not available, do you think a deep learning super resolution pipeline applied to Sentinel-2 could provide sufficient spatial detail for reliable polyhouse detection? Or would you still recommend using only native high resolution imagery?
So I will take this question. So for my polyhouse detection, I have used high resolution satellite data of 60 centimeter, which is already available with our organization. But if you want to do a deep learning, I will recommend Sentinel-2 at 10 meter is actually not advisable to do polyhouse detection using this method, because the smaller polyhouses you might be missing. For those cases, you can use different spectral indices like NDVI, then NDW, and then you can do that. If you don't have Sentinel-2 at 10 meter, obviously 2 meter will be much better than Sentinel-2 at 10 meter spatial resolution. But it is recommended to use a high resolution data if you are using through feature extraction.
Okay, so there is another question. Can Kaggle Notebook work better with hyperspectral image processing, and does pre-processing steps for hyperspectral images changes for inputting the image in the deep learning model, which is built using coding in Kaggle Notebook?
So I have not, I will be very frank, I have not worked with them, but definitely it is recommended that you pre-process your imagery and then use it for your deep learning activities so that the anomalies and the, I would say noise or anomalies are not ingested or is integrated within your model training.
Thank you, Manusha. Can you suggest which method is best for mineral identification like object detection or pixel segmentation?
Since hyperspectral imagery is used for, and it is spectra-based mineral identification that is done, I would prefer we use the spectral hourglass that was just shown, and we can automate the same using the modeler technique. So what happens is, instead of going, definitely we have deep learning models that will help us to do that. But in case the libraries are something that can be ingested, we can use the ENVI modeler to automate the entire process for different areas. The spectral library plays a major role in case of our identification.
Thank you, Manusha, for this answer. I think there are a few more questions. So I'm not clear about this question, but then I'll still read it out. Can people be detected and counted? Can there be a live counting of people in crowded areas?
So definitely, if we have a live stream video that is available, we have another offering known as I would say ENVI Edge that will help you to read those live stream as is, and there you can apply your deep learning model and you can count and detect your people there. Definitely, we can do that.
Thank you, Manusha. I think live streamed videos. Even RGS technology as well as ENVI technology both have solutions to address that. It depends on the quality or the type of the video and the formats of the video for it to be readable and work with. I hope we have addressed to all the questions that were listed down. Even more going forward, if you have more questions, please write to us at info@esri.in, right? So that we hear from you, we go through your questions and we'll respond to you as soon as possible.